Chapter 4, Mod 9. What we're going to study today is the Earth's atmosphere. What we're looking at here is this column of air, and as you notice, the particles are much closer together down here, much higher density, and it's due to the weight of the upper layers of the atmosphere. And that's down here where we live. It's really high pressure, high density. And as you go up, you get a low density and low pressure system. What we're going to do is talk about the atmosphere. It's a thin layer of gases that surrounds the Earth. It does absorb some radiation, helps moderate climate, helps keep the heat in. It also transports and recycles water and nutrients. It's part of the several cycles. The 78% nitrogen, 21% oxygen, and the other 1% is other gases. We can look at those. We're going to study its layers, different temperatures, densities, compositions. We're going to learn how human activity is changing the amounts of some of these gases as well, and the effects that the ecosystem has upon that. So if we're looking at the Earth's surface right here, this is what we're going to be discussing, the atmosphere, okay? So again, pictorial representation, 78% nitrogen, oxygen, and then several other gases in there. One that we're concerned with is carbon dioxide. It's a variable gas. We can make that fluctuate, and I believe the number is actually 0.04 now. And all of these we're going to talk about and their ability to change the temperature. Okay, they're known as greenhouse gases. Atmospheric pressure, it's the measure of force per unit area produced by a column of air, so the weight, how much does it weigh? Relative humidity, the water vapor at a given volume of air can contain. So that depends on the temperature and depends on how much the water can hold, the air can hold, okay? Temperature varies with location and time. These are all the things that deal with atmospheric properties, okay? So what we're looking at here is atmospheric pressure, and as you go up in altitude, it goes down in pressure. Okay, so as you go down, closer to the Earth's surface, you have a much higher pressure, and over here is another density with molecules. You got much more closely positioned molecules versus scattered molecules. Simple density. Saturation point. What this deals with is the temperature and the amount of water, grams of water per meter cubed, that the air can hold. So at 30 degrees Celsius, we know that the air can hold 30 grams of water per meter cubed. And if the temperature was to drop to 10, where does that water go? If it was saturated, if it dropped, it will fall as precipitation. Okay? So at 10 degrees, we can hold 10, and taking those two numbers, you can calculate percent change, finalized initial over initial times 100, just in case they throw that question out there. Weather and climate. Climate is the average weather that occurs in a given region over long periods of time. Weather is what's happening. Climate is what we expect, and weather is what we get, said old Mark Twain. Again, this is talking the difference between weather and climate, and this is example of weather, what's happening, and climate is, remember, over a long period of time. So these are the layers of the atmosphere that we need to be familiar with. The troposphere, that's where we live. Okay, the stratosphere is the next layer. And within that is this orange layer that's really important, the ozone layer. The mesosphere is the next layer, and the thermosphere. The exosphere, that deals with outer space. The ones that we're concerned with, troposphere, stratosphere, mesosphere, thermosphere. Those four. And the red line on here indicates temperature. And it's pretty wild, like in the troposphere, as you go up, the temperature decreases. But in the stratosphere, as you go up, the temperature increases. Mesosphere, the temperature decreases as you go up. And then in the thermosphere, the temperature increases a lot as you go up. So again, this is the same thing. Troposphere, stratosphere, mesosphere, thermosphere. And they have the pauses in here, but we're not concerned with those. And again, this red line indicates temperature. Okay, and I really like this graph because not only does it show very clearly the layers and then the temperature, but also shows this, which is ozone concentration. Ozone concentration is very important because it helps absorb UV, B, and C, which are cancer-causing UV radiation. Okay, so this is a large concentration of it, and then it kind of teeters off, and then down here, troposphere, you notice there's actually a little spike of it, and that's bad for us because ozone is an oxidizer, and it can affect our respiratory system. It can affect plants' ability to photosynthesize and their leaf structure. It can have bad effects on them. Okay, another little infograph I liked: troposphere, stratosphere, mesosphere, thermosphere. You need to notice in order. Up here is the ionosphere. This is mesospheres where meteors burn up. And then in stratosphere, they have ozone layer, or O3. That's why they have 3 little oxygen molecules together there. And then the troposphere is where we live, where planes fly, where the clouds form. A couple of those, closest layer. And I've seen several different numbers for this. And same thing here, I've seen 10 to 50, just kind of depends on which book you read, honestly. Different books, different numbers as far as how high it goes. Moving on, mesosphere, notice the distances, and this one's really high. This is the thickest layer, okay? Unequal heating of the earth. As the sun's energy passes through the atmosphere, it strikes the land water, it warms the surface of the earth. Now this warming doesn't occur evenly, okay? It has 3 things that really affect the unevenness, and this unevenness causes different temperatures, which can cause different forms of weather, okay? The variation in which the angle of the sun hits, the area at which more albedo or reflective nature hits, and the tilt of the Earth axis at 23. So let's look at those a little closely. So we got this coming in, you know, this is a certain, from the sun, a certain amount of sunlight, and here's the same amount of sunlight. What do you notice about these 2 circles? This one's a much smaller area, and this is a much larger area. So the same amount of sunlight, but it's spread over a larger area. So they're technically getting less available sunlight to do their plants and producers photosynthesis. Okay, so same picture as before, just another view of it. So here, direct, more direct sunlight, indirect sunlight, where it's coming at an angle, much larger, less sunlight per unit area, and more sunlight per unit area. So that helps drive the planet's atmosphere. Okay. Another thing that helps do that is albedo, the reflective nature of the Earth's surface. Some things absorb a lot of, you know, UV radiation and solar radiation, and some things reflect a lot. So albedo is the percentage of reflection of solar sunlight. Okay. So the Earth's tilt in the season. So the reason for the season is literally the tilt of the Earth's atmosphere. So if we're looking at this, well, as the Earth is tilted, it's not perfectly straight, it's tilted, and it goes around in a circle. One interesting note is that the Earth is actually closer to the sun in the winter, the summer or winter solstice, than it is in the summer. January 2nd, 2018, it'll be closer than in the summertime. Because everyone's like, oh, it's hot, it's probably got to be really close in the summertime. It's actually closer in the winter time. And this tilt of the Earth and the way it rotates around the sun causes the seasons to happen, okay? Again, the same picture, but this one's from your book. We're tilted, the northern hemisphere is tilted towards the sun, therefore this is the summertime for us, and then the southern hemisphere is tilted away, so it's the winter time, and then from summer we come into fall, then we go into winter, then we go into spring. And the spring and fall are equinoxes, and the summer and winter are solstices. That's the next thing.